Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac, Tarlac, Philippines. I always laugh when I say that. I don't know why. Okay, and you got a dog barking outside. Hopefully you can't hear that. Tonight we're talking about the Calculus 2. So this is the beginning of integration, the concepts of integration. For me, calculus really picked up speed in terms of difficulty when I went into integration because it was the opposite of differentiation. You'll recall in differentiation, let's say y equals ax to the n, and we want to take the derivative of that. Recall, we would take n, bring it down, so y prime was n ax to the n minus 1. Okay, but what happens in integration? I want to get back, if I integrate this function, I want to get back to ax to the n. I'm going one way with it, now I'm going the other way. So integrating, you use this sign, looks like a funny looking S. And what that means, you'll notice here, we step one, when we differentiated, step one was multiply by n. So we brought n down and multiplied it to the rest of the function. Step two was the fact that we subtracted, it was minus 1 from n. So we brought n down, multiplied, step 1, step 2, subtracted 1 from n. Integration, you're going to do just the opposite of that. Step 1, I want to add 1. So I'll be adding 1 to that. Step 2 is whatever I've added, I'm going to divide by that. So if I say n minus 1 plus 1 comes back to n, I'll divide by n. N's cancel and I end up with my original function. So let's try something. Let's say y equals 3x to the second power. Y prime then is 2 times 3 to x to the 2 minus 1, which is to the first power. So that gives me 6x. Okay, if I integrate 6x, I should get 3x to the second power. Whoa, pressure is on now. Okay, so let's say I integrate 6x dx. And I'll show you what dx is in a moment. So we said step 1, add 1. So I'll have 6x to the first. So I'm going to add 1 to that, and that equals 2. Then I'm going to divide by that 2. So that gives me 6 divided by 2 is 3, x to the second power. Whoa. Hey. So that is the basic tactical exercise for performing an integral. Now there's a lot more to this, obviously, as time goes along. You'll see many rules. And you know me, I'm a rules guy. So let's get after it here. Let's work a few and see what we can do. All right, we just did 3x squared. All right, look, what about 2x? If I integrate 2x dx, okay, what did I say I want to do? I'm going to, since I brought this down and then I subtracted 1, I want to add 1, do that first. So that equals 2. 1 plus 1 is 2. And I want to divide by that 2. So that gives me x to the second power. Okay, so the integral of 2x, we're saying, we'll call that we'll say y equals 2x, and we'll call this one big Y. Y equals x squared. Well, what would be the derivative of this? If I take this and I end up with little y, the derivative of x squared is 2x, which is what I started with. Okay, so that worked out. What if I had, though, well, let's say y equals 2x, and y prime, I take the derivative of that. Well, that just gives me 2, right? What's the integral of 2 dx? Well, you know, in the differentiation, you had the constant multiple rule. So you could pull the constant out and then perform the derivative. This is the same. I can pull the constant out, so that's 2 times the integral of dx. And one of the rules is the integral of dx is x. So this comes out to be 2x, actually 2x plus c. After you integrate, always put a constant of integration. And when we perform some, have initial conditions and do a differential equation, you'll see why this is important. So just know for now, and we'll get into more of this as we go. And I'll actually have a rules video and try to get as many rules as I can. There's a lot, so there may be a part A, B, and C to that video. All right. Sometimes I forget the plus C, and the teacher would be, oh, minus 1, minus 1. All right, so let's say y equals 5x cubed. Let's take the derivative of that, and that would equal, bring the 3 down, 3 times 5, then x to the 3 minus 1. So that would be 15. Can't multiply. 15x to the 3 minus 1 is 2. So 15x squared is y prime. If I were to take the integral of both of those, then how would this work out? Okay, I would take 15x squared plus 1, so that equals 3. Now I'm going to divide by 3. So we're saying y, we're going back to y. 15 divided by 3 is 5, x cubed. So x to the 3rd power. And that's what I started with. Well, go back to the plus c here. Okay. Now the dx, I should explain that. When you look at a function, let's say I have something, a function that looks like this. This is f of x. And we want to know the area of that function between, let's say, 0 and 3. So we would integrate f of x dx from 0 to 3. And when you're looking at the area under the curve, you're looking at that in terms of these little rectangles. And you'll notice, it may be hard to see, there's an arrow there. Depending on what delta x, which delta x is what we're calling dx. As delta x gets smaller and smaller and smaller, this delta x becomes the differential of x. It's infinitesimally small. And if it can get really small, then that area gets less and less and less. So that's what the dx is. We're trying to get the area under the curve of f of x from 0 to 3. So if I look at area, let's say this is y and this is delta x. Well, each one of these would be what is y, or what is f of x at this point, times delta x, and then whatever f of x is at that point times delta x, f of x at this point, and so on. So you're just looking at area. I mean, it's a rectangle. you know, y times x, or f of x times delta x, I should say. So, but to look at it infinitesimally small delta x, they're calling it dx. Okay, let's say we have y equals 3 over 2 x squared. Okay, let's take the derivative of that. We're going to use the constant multiple rule. So we're going to say 3 over 2 times the derivative of x to the second power. So that's 3 halves. Bring the 2 down times x to the 2 minus 1, which is 1. The 2's cancel, that's 3x. Okay, if I integrate 3x dx, I should get this value right here. Okay, this is to the first power. I'm going to increase that by 1, so that's 2. I should get out of there. So 3x to the 1 plus 1 equals 2. Divide that number now down here. So now it's 3 halves x squared would be my resulting, so that would go back to y. 3 halves x to the second power. Okay? Clear as mud? You just have to, as I've stated in the differentiation videos, algebra videos, learn the rules and then practice, 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 practice. I'm 64 years old. I practice math every day. And as I get older, it's amazing. I don't have the skills I did when I was younger. So, hey, practice. Don't lose those skills. Okay, here's a good one. Let's say I have I want the integral of 1 over x cubed dx. Whoa. I have an exponent in the denominator. Who cares? Let's rewrite that. So let's say that's y. And we're trying to find, well, we'll say that's y prime, and I'm trying to find the integral of that. So let's take the integral of y prime, which would give me y. And that's the integral of x to the minus 3 dx. I brought this to the numerator. Now then, what was the rule? I've got x to the minus 3 plus 1, and that equals to the minus 2. I'm going to divide that by minus 2, so that equals minus 1 half x to the minus 2, which is 1 over 2x to the second power. Okay, now then I should be able to, well, we integrated that, so now we should be able to take the derivative of that and get back to where we started. Whoa. Let's see if we can do that. I always forget that negative right there. Negative, let's see, let me clear some of this out. We're trying to get back to this. And what do we have? We have a negative 1 half x. I'll just go ahead and bring it back to the numerator. We have that. Okay? And we want to, we integrated that, so now we're going to take the derivative of that. So the derivative would be, I take the negative 2, bring it down. So I already have a negative. Now I have a negative 2. Well, let me just say I've got a negative 1 half. All right, now then, negative 2 times that, x to the negative 2 minus 1. So the 2's cancel, the negatives cancel. That gives me x to the negative 3. And that is 1 over x to the third. Okay? So far, so good. May need to clean my board here. It's so humid here in the Philippines today. I don't run any air conditioner and it's probably 95 degrees. And and I turn the fans off when I do the videos, so you can't hear the fan noise, so you probably hear my sweat dripping in on the floor. Okay, what do we got here? All right, the integral of x plus 2 dx. Now you recall from in differentiation you had a sum difference rule, and it said like the sum was the derivative of the sum of two functions, f of x plus g of x, was the sum of the derivatives. So it was f prime of x plus g prime of x, and the difference was just the opposite of that, is subtracting. This is the same. You can separate these out. So I could say the integral of x dx plus the integral of 2 dx. So here we go. I have x to the first power, add 1, that equals 2, divide it by 2, okay, plus I've got the 2, and actually bring the 2 out if you want, and then the integral of dx is x. So I end up with 2x. So I have 1/2 x to the second power plus 2x would be the integral of x plus 2 dx. Let's take the derivative of that and see if we get back to x plus 2. So 1/2 x to the second power plus 2x. Okay, and we want to take the derivative of that and see if we get back to x plus 2. So the derivative, bring the 2 down, so I have 2 times 1/2 x to the 2 minus 1 plus 2 times, bring the 1 down, so it's 1 times 2, x to the 1 minus 1. So my 2's cancel, x to the x to the first power, plus 1 times 2 is 2, x to the 0, 1 minus 1, x to the 0 is 1, so 1 times 2 is 2. So I ended up with x plus 2. All right. I haven't stumped my toe yet. Oh, I bet I shouldn't jinx myself. I had a video earlier where I was factoring out a -1 out of a parentheses, and I stumbled all over that. It was comical. I had to actually do the video again, and then almost stumbled again. It was pitiful, actually. Okay. I've got the integral of 2 over square root of x dx. Okay, you know that the square root of x can be written as x to the 1/2. Now since this is in the denominator and I want to pull it to the numerator, it's going to be x to the minus 1/2. Okay, and I'm also going to pull the 2 out, 2 integral of x to the minus 1/2 dx. Okay, all right, so that equals 2. Okay, x, I'm going to increase this by 1. 2 to the minus 1/2 plus 1. 1 would be 2 over 2 to keep a common denominator here. And that ends up being -1/2 plus 2 over 2 gives me a positive 1/2. So I'm going to divide by 1/2, which is the same as multiplying by 2. So this is 2 times 2 over 1. So I'm flipping that up. X to the 1/2. So that equals 4x to the 1/2. What was it? 4 square root of x. Okay, so that is just the basic intro to what integration is all about. Hopefully you enjoyed the video. We'll get into many more things. I'm working on the rules video now because I just think that is super important to have rules, understand the rules, give examples of the rules. If you've watched the other videos, I'm all about the rules. Because if you know the rules, that allows you to play the math game properly. Okay, enough for now. Okay, guys, we're trying to help you build a better tomorrow, and we're doing that together through math. So have a great evening, and we'll talk to you soon. Thank you.